Dear students, this is Anita Raj, your chemistry mentor. In this session, I am going to teach you to solve problems related to molarity in a simple way. If you are having any doubt regarding formulas, you can refer to my previous video. Okay, let us see the first problem. See, we are going to calculate molarity directly from the formula. Okay, so let us read the problem first. 3.46 grams of sodium hydroxide. Its molar mass is given as 40, are dissolved in water, and the solution is made up to 200 centimeter cube in a volumetric flask. Calculate the molarity. So, see, whenever you are doing the problem, first you please take down the given data so that it will be easy for you to do the problem. Okay. So, let us write the given data. Take down the given data. Okay. So, 3.46 grams of sodium hydroxide. Sodium hydroxide they have mentioned. So, it is the name of the solute. So, weight of the solute is given. Okay. So, weight of the solute. Okay. Weight of the solute, sodium hydroxide is given. So, let us, we used to represent with the term W2. It is 3.46 grams. Okay. Next, molar mass of sodium hydroxide is given. So, molar mass of the solute. So, molar mass of the solute, that is M2 is given. So, M2 is equal to 40. Okay. It's dissolved in water. So, the name of the solvent is also given, water is given, and the solution is made up to 200 centimeter cube in a volumetric flask. 200 centimeter cube represents the volume of the solution. Okay. So, volume of the solution is also given, volume of the solution. Okay. So, volume of the solution we used to represent by the term capital V, and that is equal to 200 centimeter cube. Students, you note down, see here the volume of the solution is given in centimeter cube and not in liters. Okay. Now, we are going to find out the molarity. So, how to find out molarity? First, let us write the formula. Okay. So, molarity is equal to, molarity capital M is equal to, it is the number of moles of the solute in 1 liter of the solution. Is it a number of moles of the solute in 1 liter of the solution? How to calculate number of moles of the solute? It is weight by molecular weight. Okay, it is weight by molecular weight. So, in 1 liter of the solution, see here it is the volume of the solution is given in centimeter cube and not in liter. So, since it is given in centimeter cube, you are supposed to multiply with 1000. Okay, see, if the solution volume of the solution is given in liters, you don't want to multiply by 1000. Since it is given in centimeter cube, we are supposed to multiply with 1000. Okay, now substitute all the values. What is the weight of the solute W2? It is 3.46, is it not, into 1000 divided by, what is the molecular weight given? It is 40 into 200. Okay, so we have substituted all the values. Now find out the answer. 0, 0. Now this also gets cancelled. So now 3.46 divided by 8. Find out the answer, students. It is 3.46 divided by 8. It is, what is the value? 3.46 divided by 2. It is 0.432. Okay. So, what is the unit for molarity? It is capital M. Okay. So, it is a must that you should give the units for the problems. Okay. So, molarity is represented by capital M. So, this is the answer, 0.432. Okay. I hope you might have understood. So, we shall see the next problem. Okay. So, read the problem. Calculation of mass of the solute. See, we are going to calculate the mass of the solute from molarity. Okay, using molarity formula, we are going to calculate the mass of the solute. In the previous problem, we saw how to calculate molarity directly by having all the values like weight of the solute and molar mass, etc. But here, you are going to calculate the mass of the solute from the molarity value. See read the problem. Calculate the mass of the solute in the following solution. See, the solution is 300 centimeter cube of 3 molar nitric acid. 300 centimeter cube represents the volume of the solution, okay, and 3 molar, that is molarity of the solution is also given 3. And one more thing, see nitric acid, the name of the solute is also given, nitric acid. So it is possible to calculate the molar mass also, is it not? First let us write the given data, take down the given data. Say volume of the solution is given, so volume of the solution V, capital V is equal to 300 centimeter cube, okay, and then molarity of the solution is also given, so molarity of the solution, so capital M is also given, it is 3, is it not? Then what else is given? Nothing else, right? The name of the solute alone is given. So now you are supposed to calculate the mass of the solute. So mass of the solute you want. What is mass of the solute? What? W2, right? So W2, we are in need of W2. Now find out the answer. So first you please take down the formula. So what is molarity? Molarity. See, we are seeing the problems coming under molarity, how to calculate various values using the molarity formula, okay. So W2 divided by M2 into 1000, since the value is given in volume of value is given in centimeter cube, you are supposed to have this value 1000 and then divided by V, okay. So now substitute all the values and find out W2, come on. See, what is the value of capital M? It is 3, is it not? 3 is equal to W2, we don't know, into 1000 divided by V. Okay, what is V? Given 300, is it not? 300. And we are supposed to calculate molecular mass. We don't know the molecular mass also, but we know the name of the solute. So nitric acid we know. So it is easy to calculate the molecular mass of nitric acid, okay, if you know the atomic mass of all the elements. So what is the atomic mass of hydrogen? It is 1, okay. Nitrogen, it is 14, okay. Oxygen value is 16, atomic mass is 16. Since 3 oxygens are there, so we should multiply with 3. So it is 48. So you can substitute 48 here and find out the answer. So it is 63. So nitric acid molecular mass is 63. So you can substitute 63 here. So now find out the answer, students. Find out the answer. So what is? So now we are supposed to calculate W2, is it not? So W2, we can take W2 here is equal to 3 into 63 into here we have already cancelled, right? So 3 divided by 10, is it not? Come on, tell me, find out the answer. See, it is 56.7 grams, okay. It is 56.7 grams, okay. So this is the answer. So this is how. So this is the unit for the weight of the solute, okay. So always you should have this in mind. Never forget to put the unit wherever we want to put the unit. You should make use of the units, okay. So weight of the solute is 56.7 grams, right. So we shall see the next problem now. Read the problem, students. Calculation of molar mass. So in the previous problem we saw how to calculate the weight of the solute from the molarity formula. Now we are going to calculate the molar mass. How to calculate the molar mass of the solute, okay, from the given data. So now read the problem. 100 centimeter cube of a centimolar solution of an acid contains 0.082 grams of the acid. Find the molar mass of the acid. So 100 centimeter cube, this represents the volume of the solution, is it not? So and then centimolar solution, centimolar represents the molarity of the solution. So the molarity of the solution is given in centimolar, okay, of an acid contains 0.082 grams of the acid. So acid represents, it is the solute, okay. They didn't give the name of the solute, instead they have given us acid, and 0.082 grams, it represents the weight of the solute, okay. First you take down the given data. So volume of the solution, okay, volume of the solution. V, capital V is equal to 100 centimeter cube. Okay, and then molarity of the solution. See, the molarity of the solution is given in centimolar. Okay, so it is given in centimolar. So we should convert this to molar. Okay, centimolar. How to convert this? We should divide with 100. Okay, if you want to convert centimolar to molar, we should divide the value by 100. So we will be getting the value as 0.01 capital M. So we used to represent molarity with capital M. Then what else is given? The weight of the solute is also given. So weight of the solute. Okay, weight of the solute. Weight of the solute we used to represent with W2. It is 0.082 grams. Okay. So now we are going to find out the molar mass. How to find out the molar mass? We can find out the molar mass easily from the molarity formula W2 by M2 into, see here the volume is given in again in centimeter cube. So you are supposed to multiply with 1000 divided by, what is the volume value? It is 100, is it not? Okay, so now we know W2 also, we know W2. So you can substitute the value, you know the molarity value also. So it is 0.01 into W2, it is this is equal to sign 0.082 into 1000 divided by M2 into 100. Okay, now you want this molarity. Okay, we are in need of this molarity. So you can bring this here. M2 is equal to, come on, do the problem, 0.082 into 1000 divided by 0.01 into 100. Come on, do the problem, students, find out the answer. See, yes. So the answer is 82 grams. Okay, it is 82 grams per mole. See, the molecular mass should be represented like this. The unit of molecular mass or the molar mass is 82 gram per mole. Understood, students? For weight it is gram, for molarity it is capital M, for molecular mass it is gram per mole. Okay, so I hope you might have got this answer. So do and see, and now we shall see the next problem. Okay. Okay, now see the next problem. Calculation of molarity of a pure solvent. It is different. See, in the previous problems we were calculating the molarity of a solution, right? Now here we are going to calculate the molarity of a pure solvent. How to calculate the molarity of a pure solvent? Here we don't have any solute, right? So now the problem goes like this. Calculate the molarity of pure water at room temperature if its density is 0.998 gram per centimeter cube. Calculate the molarity of pure water at room temperature if its density is 0.998 gram per centimeter cube. The only data given is the density, is it not? So density alone is given. What is the density of water? Density of pure water is given, is it not? Density of pure water. Density of pure water is given as 0.998 gram per centimeter cube. See, if you want to calculate the molarity of a pure solvent, it can be found out by calculating the number of moles of the solvent. Okay, it is possible. See, if you want to find out the molarity of the pure solvent, we can calculate by finding out the number of moles of the pure solvent. How to find out the number of moles of the pure solvent? By finding out the mass, by knowing the mass of the pure solvent and the molecular mass of the pure solvent. How to find out the mass of the pure solvent? Nothing else is given, is it not? So only density alone is given. So by using the density formula, it is possible to find out the mass of the pure solvent. See, the formula goes like this. Already in your earlier classes you might have learnt density of the solution. See, a solution or whatever. See, it is mass by volume. Density is equal to mass by volume, right? See, if you know the volume of the solution or the solvent and the density, it is possible to calculate the mass. So, if you know the mass and if you already it is given water, so it is possible to calculate the molecular mass. So, if you know the mass and molecular mass, it is possible to calculate the number of moles. So, number of moles of water present in 1 liter is equal to molarity. Understood, students, for pure solvent, okay? So, now we are going to find out the mass of the pure solvent, that is water, okay? So, now let us see, just we'll find out the mass of the solvent, okay? So, now write like this, its mass of 1 liter. 1 liter is nothing but 1000 centimeter cube, okay? So, 1000 centimeter cube of pure water, So, we are going to calculate the mass of 1 liter of pure water, that is equal to density into volume, okay? Density into volume. So, already we know it is 1 liter. So, mass of 1 liter, so is equal to density, what is the value? 0.998 into the 1000, okay? So, 1000 centimeter cube. So, now the value is 998 grams. So, the mass of the pure water is 998 grams, okay? So, molecular mass of water, okay? Water is, it's 18, okay? How to find out the molecular mass of water? H2O, you know, is not hydrogen, since it is 2 hydrogen, so 2 oxygen 16, so it is 18, okay? So, that's why 18 I have written here. Now, we are going to calculate the number of moles. So, number of moles of water present in 1 liter, okay? Number of moles of water present in 1 liter is equal to, that is 1000 centimeter cube, is equal to mass by molecular mass, that is equal to, what is the mass? 998 divided by 18, okay? So, the answer is 55.44 m. See here, see, number of moles present in 1 liter is equal to molarity, okay? Number of moles of, because we are not using any solute here, it's a pure solvent, okay? So, the number of moles of water present in 1 liter is equal to molarity of pure water. So, the number of moles is equal to molarity. So, the answer is 55.44 m. So, this is the answer. Understood, students? Okay, we shall see the next problem now. Okay, next problem. We shall see the next problem. Calculation of molarity from mass percentage. Calculation of molarity from mass percentage. Okay, so mass percentage. What is mass percentage? What is mass percentage? First, I'll teach what is mass percentage. How to calculate mass percentage? Mass percentage is nothing but weight of the solute divided by weight of solution into 100. Okay, so this is mass percentage. So from this value we are going to find out the molarity. Okay, so now read the problem. Concentrated sulfuric acid has a density of 1.9 gram per ml and is 97% pure sulfuric acid by weight. Calculate the molarity of sulfuric acid in this acid. See, it is not a complicated problem. It is easy only. Just read the problem once again. Concentrated sulfuric acid has a density of 1.9 gram per ml. See, they have given the density of sulfuric acid, okay, concentrated sulfuric acid. And one more thing, they have given 97% pure H2SO4 by weight. 97% pure H2SO4 from weight. Here we have the clue. See, 97% by weight means it is mass percentage. That is 97 grams of sulfuric acid is present in 100 grams of the solution. Understood, students? 97 grams of sulfuric acid is present in 100 grams of the solution. So, the weight of the solute is also given, weight of the solution in 100. Okay, that is mass percentage. So, this value is mass percentage. Understood? Weight by weight. Okay. So, you can directly substitute. Now, let us write down the given data. Density of the solution is it is 1.9 gram per ml. Okay, and what else is given? Students? It is mass percentage. Mass percentage is also given. Mass percentage of the solution. Solute. Okay, mass percentage. It is also given. So it is 97% mass percentage. Okay. Now we are going to find out the value. Okay. Solution. So what is the formula for relating the molarity and mass percentage, students? What is the formula? Molarity M is equal to mass percentage into density into 10 divided by M2. Okay, so this is the formula. So directly you can substitute all the values. You don't want to go in search of weight of the solute or weight of the solution or etc. etc. Okay, directly you can substitute the values. So what is mass percentage? It is 97. What is density? It is 1.9 into 10 divided by molecular mass. So molecular mass alone, M2 alone you are supposed to calculate. Okay, for sulfuric acid, H2SO4. Okay, how to calculate? See, 2 hydrogen atoms, right? So the atomic weight we can substitute as 2. Sulfur, it is 32. Okay, oxygen, we are having 4 oxygen atoms, so it is 16 into 4. Okay, so 64. So we can substitute 64. What is the answer? It is 98. So substitute 98 here and find out the answer. See, it is so simple. Okay, it is a simple calculation. The 1843 divided by 98, that is equal to 18.8. Okay, 18.8 m. Okay, so this is the answer for molarity. This is how we should calculate molarity from mass percentage. Understood, students? Hope you might have understood all the problems. Okay, let us see problems related to molarity in the next session. Thank you.